Today's intro will be performed by one of my students, Joseph.
Hello everyone and welcome back to another math video. Today we will be talking about probability of independent and dependent events, similar to the problems that you see up on the screen. Just a reminder that this is the normal version of the lesson. If you would like the speedrun version where we go through the problems pretty quickly, I will link that in the description below. Okay, your Ricasso Recap starts now. In 30 seconds or less, here's what you need to know before you start this lesson.
Okay, firstly, you should know how to multiply fractions or have a calculator that can help you with that. Secondly, you should already have an introduction to probability, and you should know how to calculate it. You should know some of the terminology. You should know how to, percentages, rounding, all of that is involved in probability, things like prime numbers, divisors, factors, all that. So if you want refreshers on either of these two topics, I will link videos in the description below. Please go watch those before you start this lesson. All right, new lesson starts now. Here we go. It says you roll a 6-sided die 2 times, and then it says what is the probability of rolling a factor of 64 on the first roll, and then rolling a prime number on the second roll. So let's start with rolling a factor of 64. We could list out all the factors of 64, but ain't nobody got time for that. Let's just think about the numbers that are on our die. 1, 2, 3, 4, 5, and 6. Which one of these are factors of 64? 1 is, 2 is, 3 is not, 4 is, 5 is not, 6 is not. So that's 1, 2, 3 numbers out of the 6 possibilities. All right. Now, what about rolling a prime number? Well, again, maybe we should just list out. Remember, prime numbers, a little refresher here, are numbers that can only be divided by themselves in 1. And so 1 is never a prime number. 2 is, 3 is, 4 is not, 5 is, 6 is not. So also 3 out of 6. And now to find the probability of both of these happening, right, of rolling a factor of 64 and then rolling a prime number, what's the probability that I get that sequence of rolls or that order of rolls? Well, the way we do that is we multiply our probabilities. 3 over 6 times 3 over 6 gives me 9 over 36. You could reduce that if you want, but you don't have to in this lesson. And it says write your answer as a percentage. So we need to multiply this by 100, which will give us 25%. 25%. All right, here's our cool clock for today, which means that it is time for you to practice what you just learned. Go ahead and pause the video and try these 2 problems on your own. And when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, here is the work, and the final answer should have been 2 over 16. If you wanted to reduce that, you could put 1 over 8. Notice it says write your answer as a fraction or whole number, so either one is correct. And for the second problem, should have gotten 1 over 4. Okay. Now let's look at a different type of problem. It says you pick a card at random without putting the first card back. That's important. You pick a second card at random. So these are called dependent events because when I pull the first card and I don't put it back, that means I've now changed the probability for the second card pull. So they depend on each other or they affect each other, right? That's what dependent events are. At the beginning, we were looking at independent events, right? When I flip a coin and then I flip a coin again, okay, the first flip does not affect the second flip. It doesn't change the second flip. But here, all right, the first, when you first take a card, definitely affects, and then you don't put it back, that definitely affects the second card pull. All right, so now let's look at this. What is the probability of picking a 2? So from all the cards, 2 is 1 out of the 4. Now remember, we don't put it back. So that 2 is no longer in the deck. Now, what is the probability of picking a factor of 27? Well, 1 is a factor of 27, 3 is a factor of 27, 4 is not. So there are 2 out of the 3 remaining cards. And now we just do our same process, multiply the fractions. We get 2 over 12. It says write your answer as a percentage, rounded to the nearest tenth. So we need to multiply by 100. And that will give us 16.6 repeating. And it says rounded to the nearest tenth, so that would be 16.7%. Final answer. Again, these are dependent events. All right, time to practice. Go ahead and pause the video, try these two problems on your own. When you're ready, unpause and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the work. You should have gotten 12.5%. Notice that they had some tricky wording, right? We just looked at card problems, but in this card problem, you put the card back. All right, so that means that you have a 2 out of 4 chance of pulling an odd number on the second pull. Okay, a little tricky there. Okay, for the second problem, a little tricky. Okay, it says, what's the probability of pulling an odd number? The only odd number is the 5, so that's 1 out of 3. And then it says you don't put the first card back, so all right. And then it says, what's the probability of now picking another odd number? Well, there are no odd numbers left in the deck, right? Because you didn't put the 5 back in, so it's 0 out of, and I should have put 0 out of 2 options. And then you multiply your fractions. 1/3 times 0 over 2 gives you just 0. All right, that's it for today. I hope you all have a good morning, good afternoon, good evening, and good night.